Hi class, in this lecture here we want to learn a method of differentiation called the chain rule. Now this chain rule is a very, very important method of differentiation. And as I introduce this topic, it's going to seem a little weird at first, but I promise you after I do a couple of examples, you're going to start seeing the pattern of how to apply the chain rule, and it's going to make sense. The only other thing I will say is this lecture is long and there's going to be a ton of examples in this lecture. So if as you're working through this lecture, if you need to pause the video and take a break and come back, or as we get into different sections or different topics, pause and come back, you should definitely do that. Okay, so what are we going to do in this section? All right, so what we're doing in this section. So the first thing we're going to do is we're going to find the derivative of a composite function. Okay, so just as a quick refresher, what is a composite function? That's something like this, f composition g. So this would be f of g of x. Okay, and we're gonna find this derivative of this composition function using the chain rule. So I'll introduce the chain rule there, and then we're gonna find the derivative of a function using what's called the general power rule. This is also just an extension of the chain rule. Right, you're going to see, after I do a couple problems using the chain rule, you're going to see how the power rule comes into play. All right, and then what we're going to do is we're going to talk about finding the derivative of transcendental functions using the chain rule. So, the trig functions, e, things like that, exponential functions, I mean. And then we're going to find the derivative of a function involving the natural logarithmic function, so ln. And then we're going to define and differentiate exponential functions that have bases other than e. And so there's going to be a lot of formulas. So what you should do is, maybe consider even making a little note cheat sheet of all the formulas that are introduced so that you have them handy. And let's jump right in. Okay, so what is exactly the chain rule? All right. So if y is equal to f of u, okay, so we have this u variable inside here, is a differentiable function of u, but u is a differentiable function of x, so u is equal to g of x. Then y is equal to f of g of x, so this is the composite function, is a differentiable function of x. And dy dx, so the derivative of y with respect to x, is equal to the derivative of y with respect to u times the derivative of u with respect to x. All right, or equivalently, there's a little typo here. The derivative of f of g of x is equal to f prime evaluated at g of x times, and this is a little typo, g prime of x. And you're going to hear me say this a bunch in these slides. It's going to be the derivative of the outside times the derivative of the inside. Okay, and I'm going to do an example with this notation here. Even with our first example, okay, so you're gonna, and then I'll do an example when I talk about the derivative of the outside times the derivative of the inside. Okay, so keep this in mind here. But as I said here, when applying the chain rule, it's helpful to think of composition function f composition g as having two parts, an inner part and an outer part. Notice how I said that, even on the last slide here, inner and outer. Okay, so this f is the outer part, and the g of x is the inner part of the function, okay? So the derivative of y is equal to f of u is the derivative of the outer function at the inner function u, I'll explain that, times the derivative of the inner function. So y prime is equal to f prime evaluated at u times u prime. Okay. So it's okay to look at this and be a little confused, like, what exactly is going on here? I've had this f of u, but u is a function of x itself. It's a little weird. So let me introduce this with an example. Okay. So let's find the derivative of the following. All right. So I'm gonna show you how to do this three ways. Okay. So here'll be the first way. So y is equal to, in parentheses, 3x plus 2 squared. All right, so if you wanted to find the derivative, okay, without using the chain rule, all right, what you would have done is you would have said, okay, well, this is, this is 3x plus 2 times 3x plus 2. And so if you FOIL this out, you end up getting, just to save some time, if you FOIL it out, you end up getting 9x squared plus 12x plus 4. All right, and so if we want to differentiate this, okay, dy dx, all right, you would just use the general power rule, right? Bring the exponent down. 9 times 2 is 18. X, you get 2 minus 1 is 1, so it would just be x. And then the derivative of 12x is just plus 12, and that goes away. So this is the derivative. So you could have solved it just very, very simply with algebra. All right, now let me show you this notation here. This dy dx is equal to dy du times du dx, okay? So I have this function. Y is equal to 3x plus 2 squared. Notice that 3x plus 2 is, listen to how I say this is really important, is inside of the parentheses, okay? So I'm going to let u be equal to 3x plus 2, okay? So then that means y is equal to u squared. So look, dy dx is equal to, just even going back, dy du times du dx. dy du times du dx. All right, well, look. Let's find the derivative of y with respect to u. Well, I have y is equal to u squared. So that just becomes 2u times, and now du dx, I look at my u, and if I differentiate u with respect to x, well, that's just 3, right? Because 2 is a constant, goes away. So times 3. So this is equal to 6u. Well, my original problem was in terms of x, so I have this u here. That's weird. Well, look, let me plug back in what u is. So this is 3x plus 2. And now watch what happens when I distribute the 6. 6 times 3 is 18x. 6, well, look at that. I get the same thing. So this was solving it with this change of variables, with this going back, letting u be equal to the inside part. All right, notice how I'm accentuating there, the inside. All right, let's try this again. All right, here's another way. Y is equal to 3x plus 2 squared. Okay, so look, this is the inside. And what's on the outside is this square. All right? So this is how I like to do these problems, okay? Instead of, doing this change of variable stuff. I like to say, okay, take the derivative of the outside. So dy dx is equal to. So you take the derivative of the outside. Well, the derivative of an outside is the square. So you're just going to apply the power rule. So you're going to bring the 2 down in front, leave the inside alone, and then the 2 becomes 2 minus 1, times the derivative of the inside. Well, now look at the inside. What is the derivative of 3x plus 2? That's just 3. So look, 2 times 3 is 6. 3x plus 2. 2 minus 1 is just 1. Well, now look. Now distribute the 6. You get 18x plus 12. So that's very, very, very easy right there, right? One of the things you might say is, well, Matt, why would I even bother trying to do any of these when I could just FOIL this out? Absolutely. Absolutely. But let me show you why you need to use this chain rule reason, okay? So let me put a much harder one that you just really can't FOIL out. You're going to need to apply the chain rule. All right, so let me go to the next slide here. So let's find the derivative of the following here. Let's try this one. Let's look at f of x is equal to 4x plus 2 to the 7th power. Okay. So now here's what you don't want to do, right? What you don't want to do is you don't want to say, okay, well, let me write 4x plus 2 7 times and then just distribute that out. Oh my gosh, that sounds terrible. So look what's going on here. Notice how I say this. Inside, outside. So let's let u be the inside. And this is what I have then. F of u now, okay, ends up being u to the 7th power. All right. So then the derivative here, the derivative of this, look, going back, is f prime evaluated at u times u prime. Okay. See this right down here where my mouse is? So f prime of u is equal to. So I'm going to differentiate this. This 7 comes down. So this becomes 7u to the 6th power times u prime. U prime. Well, I got to find what the derivative of u is. Well, watch what happens here now. So f prime of x, when I switch this back to the x variable. So this is 7 times u to the 6th power. But what is u? U is 4x plus 2 times u prime. Well, what is the derivative of this right here? Derivative of 4x plus 2 is just 4. So this ends up being 7 times 4 gets me 28 times 4x plus 2 to the 6th power. Sometimes doing this change of variable is a little confusing. So let me show you this one right here. Let's find the derivative of this. F of x is equal to 3x minus 4 to the 3rd power. Okay. This is, look what's inside the parentheses. So this is inside. And the exponent is the outside part. So using the chain rule, it's the derivative of the outside. So let me differentiate this exponent. Let me bring the 3 down. I'm left with 3x minus 4 squared, right? Because I'm just doing the power rule. And then it's times the derivative of the inside. Well, the derivative of 3x minus 4 ends up just getting me 3. Well, 3 times 3, this ends up being 9 times 3x minus 4 squared. So maybe this one is a little bit easier. I'm gonna be doing both notations, both methods, as we go through these going forward. But hopefully you're starting to see the pattern. This now brings us to this general power rule, okay? So if y is equal to u, which is a function of x raised to the n power, okay, where u is a differentiable function of x and n is a rational number, okay? So a rational number just has to be of this form, a over b. Then dy dx, look what I'm doing here, all right? You're just applying the power rule. The exponent comes down, so the n comes down. The u of x stays, so the inside, notice the inside always stayed, all right? Raised to the n minus 1 power times the derivative of the inside, or du dx. Or equivalently, if you have the derivative here, all right, so this is a little bit of a typo here. So the derivative with respect to x of u to the n, just bring the n down, then you have u to the n minus 1 times u prime. All right. Let me show you some examples of this, just so you can see exactly what's going on here. All right, so let's find the derivatives of these. All right, let's look at this one. Let's look at y is equal to the square root of 2x plus 1. All right, so what we know, the way we used to solve this, okay, square root was you would just write this as 2x plus 1 to the 1/2 power. All right, now here's what you can do, okay? Notice how the 2x plus 1 is inside the parentheses. So I'm going to let u be equal to 2x plus 1, all right? So then I have y is equal to u to the 1/2 power. Okay, so look, just apply this power rule. Bring the n down, okay? So dy dx, or y prime here, if you want to just use that notation, is equal to, bring down the 1/2. This becomes u to the 1/2 minus 1. And then you need to find u prime. All right, well, look. Y prime, the derivative. This is 1/2 u. All right, well, what is u? I said u is equal to the inside. 2x plus 1. All right, to the 1/2 minus 1, so that's minus 1/2. And then the derivative of u, well, the derivative of 2x plus 1 is just 2. So look what happens here. This one worked out nice. Okay, 1/2 and 2 goes away, and this ends up just being with the negative exponent when I move it down, 1 over the square root of 2x plus 1. All right, let's try another one. And I'm going to do it without using the u notation. I'm going to do the, as Matt says, inside, outside. So let's look at this. Let's let y be equal to the third root of x cubed plus 2 squared. All right, well, look at this. I'm going to write the third root as the 1/3 power. So I have x cubed plus 2 squared raised to the 1/3 power. Well, an exponent to an exponent, you multiply. So this 2 times 1/3. So this is really x cubed plus 2 to the 2/3 power. Look, this is the inside, and this is the outside. All right? So our derivative, y prime here, take the derivative of the outside. So just apply the power rule. Bring the exponent down in front. This is 2/3. Leave the inside alone, x cubed plus 2 to the 2/3 minus 1 times the derivative of the inside. Well, the derivative of x cubed here is 3x squared, and derivative of 2 is 0, so it's just 3x squared. Well, look, the 3 and 3 here will cancel, right? Because the 3 in the denominator here in the numerator. So you're just left with 2x squared times, and then this becomes x cubed plus 2. 2/3 minus 1 gets me minus 1/3. So then just bringing the negative exponent down, this ends up just being 2x squared all over the third root of x cubed plus 2. So there's a lot going on here, as you can see, right? Like there's a lot of algebra in this. So the key to solving these problems correctly is to just take your time. Always take your time. All right, let's do some rational functions here. Okay. Let's try this one. So again, what we're going to do, we want to find the derivatives of the following here. Okay. Let's look at this one here. Let's look at f of x is equal to, let's look at -3 all over 2x plus 1 squared. All right, well, it's like, oh, well, I got a rational function here. What am I going to do? Well, look, I can bring this 2x plus 1 squared up as, so this is -3 times 2x plus 1 to the -2 power. So look, there's a couple things you could do. I'll keep doing this, u notation first. So let's let u be the inside. So then this function becomes f of u is equal to -3 u to the -2. So f prime of u is equal to, just going back, watch, all right? Even here, f prime of u, so you take the derivative, evaluated at u, times u prime. Right. So just apply the power rule. So this is -3, bring the -2 down, and then you have u to the -2 minus 1 times u prime. Well, then now let's put it back in terms of x. So f prime of x is equal to -3 times -2 is +6. Now instead of u, my u was 2x plus 1. -2 minus 1 to the -3rd power. And then what's the derivative of u? Well, look at the derivative of 2x plus 1. That's just 2. So this ends up being 6 times 2 gives me 12, and then I'm going to bring the negative exponent down, 2x plus 1 cubed. All right, let's try this one. Let's look at f of x is equal to 2 divided by the square root of 5x squared minus 3. A little bit crazy here. All right, so the key is you have to rewrite this. So I'm going to rewrite the square root as 1/2 and then bring it up as negative 1/2. So this is f of x is equal to 2 times 5x squared minus 3 to the minus 1/2. So then look, inside, and then the negative 1/2 is outside. So f prime of x is equal to, all right, this constant's not going anywhere, it's staying there. So there's that 2. So take the derivative of the outside. So bring the negative 1/2 down, leave the inside alone, and you have minus 1/2 minus 1 times, and then you take the derivative of the inside, okay? So 5x squared, the derivative of that is just 10x, and then the minus 3, that's 0. So look what's happening here. This 2 times negative 1/2 is negative 1, so I have negative 1 times 10x, so I have negative 10x times 5x squared minus 3 minus 1/2 minus 1 gets me minus 3/2. So then just, bringing the negative exponent down, I have minus 10x divided by 5x squared minus 3 to the to the plus 3/2 power, sorry. So you can see, what's going on here, right? You just gotta be meticulous. You gotta take your time, and there's a lot of opportunities to make a mistake here. But if you take your time, follow the formula, it works out.